Okay, now we're going to work an example of finding the domain of this function right here. And this is a rational function because we have a denominator, but it's also a radical function because we have a root. So when we're solving these, we want to find the domain of the numerator. So here the numerator is a radical function, so we need to take our um, x minus 2 and make sure that that is greater than or equal to 0. And then we need to apply to the domain of our numerator the restrictions in domain created by the denominator. So we're going to start by just finding the domain of our numerator. So we're going to take x minus 2 and make sure that that is greater than or equal to 0. So we're pretty much just making sure that we don't have a negative in our radical here. So if we solve, we have x is greater than or equal to positive 2. So this is the domain of our numerator here. So this is the domain of our function, and as long as we apply the restrictions in domain created by the denominator to this domain right here. So in order to find the restrictions in domain created by the denominator, we're going to take our denominator and set it equal to 0. So x plus 4 multiplied by x minus 7, that's our denominator, and we're going to set that equal to 0. So when we're solving this, we just take each of these individually equal to 0, and we're going to end up with x equals negative 4 and x equals positive 7. So when x is negative 4 and when x is positive 7, we're going to have a 0 in our denominator, so that's not going to be in the domain of our overall function. So the domain of this function here is going to be x is greater than or equal to 2 as long as x is not equal to negative 4 and as long as x is not equal to 7. Now if we think about this a little bit more, when we say that x has to be greater than or equal to 2, we are kind of automatically excluding this negative 4 value. So this value right here doesn't necessarily need to be reported, so we can just say x has to be greater than or equal to 2, except x cannot be equal to 7. So this is the domain of that function right there. And just to go a little bit further, I'm going to do interval notation for this. So a lot of times writing your domain out like this isn't enough, and you have to give it in interval notation. So I'm going to do that. The best way to do interval notation is just to draw a number line and then put all your key points on the number line. So our key point for our numerator here was positive 2. So I'm going to write that on the number line. 7 is also important, and then negative 4. So now that I have all of my points, I know that my domain is going to be x has to be greater than or equal to 2. So if we graph that out, it's going to be a solid line here and shaded in just like this. So that covers this right here. And then I also have these two restrictions. One is going to be at 7, so that's going to be right there. And then this negative 4 restriction over here. So kind of like we mentioned earlier, we don't really have to worry about the negative 4 since it's already covered in the x greater than or equal to 2 part, but we do have to worry about this 7. So when I'm doing my interval notation, I'm going to want a closed bracket for my 2 since we are including 2, and I'm going to want to go until 7. So until 7, but I'm going to use a parentheses here because this 7 is not included in the domain. And then I want everything after 7 though. So I'm going to union this with everything after 7. So I have 7 with a parentheses and then all the way to positive infinity. And when we write infinity, we always use our parentheses. So this is going to be the interval notation of that domain.